Generative AI is transforming the field of ethical hacking by bringing unprecedented efficiency, precision, and adaptability to both offensive and defensive security operations. On the offensive side, AI automates critical tasks such as vulnerability scanning, reconnaissance, and penetration testing, enabling faster identification of weaknesses and more effective simulation of real-world attack scenarios. It can dynamically adapt exploitation techniques in real time, increasing the accuracy and success rate of simulated breaches. On the defensive side, AI significantly enhances threat detection by analyzing vast amounts of security data, identifying anomalies, and predicting potential attack patterns before they occur. Automated response systems powered by AI can rapidly contain and neutralize threats, minimizing damage and downtime. This dual capability allows ethical hackers to proactively strengthen defenses, anticipate evolving risks, and create more resilient cybersecurity strategies, ultimately ensuring organizations are better prepared against the ever-changing digital threat landscape. Generative AI is revolutionizing cybersecurity by simultaneously accelerating the speed, scale, and sophistication of attacks while significantly enhancing defensive capabilities, a pivotal shift comparable to the transformative impact of cloud computing. On the offensive side, it lowers technical barriers, enabling even inexperienced actors to execute complex cyber attacks. AI automates exploitation processes, rapidly identifies vulnerabilities, and facilitates large-scale, hyper-personalized social engineering campaigns that are far more convincing and difficult to detect. On the defensive side, it delivers superior threat detection by analyzing massive data sets for subtle patterns, anomalies, and early indicators of compromise. It also automates incident response workflows, enabling faster containment and recovery, while predictive analytics help security teams anticipate and prepare for emerging attack patterns. This dual capability is reshaping the cybersecurity landscape, requiring organizations to adopt innovative, AI-driven strategies to remain agile, resilient, and competitive in an increasingly dynamic threat environment. Emerging AI-powered attack vectors are transforming cyber threats by amplifying the speed, precision, and realism of traditional techniques. Hyper-personalized phishing now uses advanced AI to craft contextually aware messages with perfect grammar tailored to the target's behavior and convincingly mimicking trusted contacts to bypass suspicion. Intelligent vulnerability discovery employs autonomous systems capable of detecting and exploiting zero-day flaws, dynamically refining attacks in real time based on system responses. Deepfake-driven social engineering leverages sophisticated voice cloning and synthetic video generation to impersonate individuals, even bypassing biometric authentication. A recent AI-powered cyber attack against a global financial firm demonstrated this evolution. Attackers deployed AI-generated phishing emails to steal credentials, then used deepfake video calls to impersonate executives, authorizing fraudulent transactions. This case underscores how AI is enhancing traditional attack vectors, creating multi-layered adaptive campaigns that are faster, stealthier, and far more effective than conventional methods. AI-enhanced penetration testing is transforming traditional security assessments into a faster, smarter, and more adaptive process. In the reconnaissance phase, AI processes vast data sets from multiple sources to uncover hidden relationships, map complex infrastructures, and generate comprehensive target profiles that would take human testers far longer to compile. During exploitation, machine learning models identify the most effective attack paths, predict likely defensive responses, and adapt techniques in real time to maximize success while minimizing detection. In the post-exploitation stage, AI assists with privilege escalation, lateral movement, and stealth operations, adjusting tactics dynamically to evade security systems. Finally, natural language generation automates the creation of highly detailed, context-rich reports and prioritized risk assessments, providing stakeholders with actionable insights. Artificial intelligence-powered defensive countermeasures are transforming cybersecurity by introducing intelligent, adaptive systems capable of detecting and neutralizing threats with unprecedented accuracy. Machine learning models continuously perform behavioral analysis, establishing detailed baselines for normal user and system activity to detect anomalies that may indicate malicious activity. Adaptive authentication further enhances protection by dynamically adjusting security measures, such as requiring multi-factor authentication or restricting access based on real-time risk assessments and user behavior patterns. Meanwhile, deception technology leverages AI-managed honeypots and decoy environments that convincingly mimic legitimate systems, luring attackers into controlled traps and gathering intelligence on their tactics. Structured frameworks are critical in AI-driven security testing, ensuring that every phase, from reconnaissance to reporting, is conducted with consistency, thoroughness, and alignment to industry best practices. Ethical hackers must now merge strong AI literacy with traditional penetration testing skills to remain effective, as AI transforms how vulnerabilities are discovered, exploited, and documented. Alongside these technical shifts, new ethical considerations arise regarding the responsible use of AI in offensive security, particularly around autonomy, potential misuse, and compliance with legal boundaries. For example, AI-powered tools like Deep Exploit and Recon and GAI outperform traditional methods in both speed and adaptability. Deep Exploit autonomously identifies and executes optimal attack paths while learning from each step, whereas Recon and GAI processes vast datasets to uncover hidden assets and relationships that manual analysis might miss. Compared to conventional approaches, these tools deliver richer insights and faster results, but their autonomous nature demands strict oversight, governance, and ethical controls to ensure responsible and secure deployment.